So we have to find out maximum okay, maximum shear stress. Now maximum shear stress, we have got this okay, so please take this again. Let us call that as 2 theta 2, the direction on which shear stress will be maximum. Let us call that direction as direction 2. No, direction 2 was already there, 1 and 2. But anyway, theta 2, anyway, let us call it theta 2. So that is theta 1, this is theta 2. So 2 theta 2, so that becomes equal to sine by, so that is becoming, yes, minus sigma x minus sigma y by 2 divided by tau xy. This is the angle, and therefore theta 2 is the direction, and that will become tangent inverse minus okay, you can find out this. So again there will be two roots. That is theta 2 dash and theta 2 double dash. Or we can say it will be 2 theta 2, then 2 theta 2 plus pi, or we can say that it will be theta 2 plus pi by 2, obviously pi by 2. The directions are actually separated by only pi by 2, we are only expressing. So 2 theta 2, and you must have also seen now, this is, if I multiply, what is interesting is that if you take tangent twice theta 1, multiply that by tangent twice theta 2, that is coming out to be minus 1. So this means something. This means something, yes, twice the angle, two angles are separated by 90 degrees. The 2 theta 1 and 2 theta 2, they are separated by 90 degrees. This you must be knowing. If this is equal to minus 1, so that means the roots of therefore the roots two theta 1 and 2 theta 2, I don't know. Ramayana is over. You tell me what is theta 1? Tell me. When sigma x is maximum, sigma x dash is maximum. Theta 2 is, just see here, what is it, theta 2? Because you must have come late. So what is theta 2? When this one is maximum, when the shear stress is maximum. So that means the roots 2 theta 1 and 2 theta 2 are separated by 90 degrees or pi by 2. That means there is angle between theta 1 and theta 2 45 degree. If 2 theta 1 90 degree means what? If this is one direction, this is theta 1 and this is theta 2, then this angle should be. So therefore the difference between theta 1 and theta 2 should always be equal to pi by 4, 45 degrees or pi by 4. So this is maximum shear stress and maximum normal stress. The planes, if you draw the normal to the planes, they will be separated by 45 degrees. Now whether positive 45 degree or negative 45 degree, that has to be found out. Whether theta 1, if this is theta 1, theta 2 will be further this side or it will be on this side. That has to be found out. But the difference will be always, this difference will always be 45 degrees. Always. So these are some very important results, and they cannot be forgotten or one should know. But again, these are very important for not only civil engineers, civil, mechanical, chemical, metallurgy and materials. Metallurgy and materials, they go together. Now there is, see, earlier it was only steel making. They were learning only steel making. Now they are learning also how to make new materials. So not only steel, which was already, the process was known, how to make steel. So this is so in material science you cannot do good material science unless you know the good knowledge about stresses, strains, transformation of stresses. Then you simply cannot do it. So somehow our people are not realizing that. Like a good medical science, you cannot do it without mathematics. Without mathematics, higher mathematics, you cannot learn the intricacies of advanced biomedical or biological, phenomena. They involve a lot of mathematics, biological phenomena. So earlier our concept was, yes, after 10th class you go into biology group or mathematics group. Biology means, yes, they can follow medical, and this one they can take engineering and technology. Now that is also gone. You must know basic mathematics, good mathematics for both biology and engineering. It is wrong, so that is why doctors, good doctors, who are doing, who are real super specialists, they have to know good mathematics. So these are some notions. Now Britain has made mathematics compulsory. They have made science and mathematics compulsory for everybody, all children. You then, in addition to this, you study philosophy, history, geography, whatever you want to learn, arts, music, but then this one is compulsory up to higher secondary stage, mathematics and biology both. So this is how it should be. Okay. So this one we got, that is now if you substitute, so this one we got. So it is very easy now to, at least you have got idea about these principal stresses, principal strains. So what is the value of maximum shear? What is the maximum? Substitute the value of 2 theta 2, tangent 2 theta 2. So substitute tangent 2 theta 2 equal to minus sigma x minus sigma y by 2 divided by tau xy. This is the expression in substitute this. So once you substitute this, let us call that 1 and 2. Of course 1 and 2 will be same, but then direction will be only changing here. After we substitute, this you don't say that this is shear maximum, shear principal. It is, we don't call it principal shear stress. No, principal word is used only to maximum normal stress and the plane on which it occurs. This is the direction. So once you substitute this, so this will come out to be, I think now we'll have to have a minus sign. So minus sign means how to do it. Tangent 2 theta. Anyway, it comes out to be this only. Substitute this. So yes. So that means my element has now moved from x direction so this, let us call this a 1 and 2 dash, 1 dash, not 1 2, otherwise this will be confusing for principal direction. 1 2, 1 dash 2 dash. So this is 1 dash and this is 2 dash, and this angle is theta 2, and here you will find, here this is see, 2 has no meaning except that it is a minus sign. 2 dash has no meaning except that it has minus sign. Yes. What about this? What about the value of substitute? What is the value of this one? So sigma, silence please. Yes, what is sigma 1 dash direction and 2 dash direction? हाँ? यही वो तो खैर हमेशा because why only first term will come ना, क्योंकि substitute this value of theta उसमें जो भी, so you will get this, therefore substitute again this angle in the formula for sigma x dash, this value of tangent, this one you please substitute this value of tangent in the formula for sigma x dash, so you will find that it comes out to be sigma x plus sigma y by 2. So that means on this plane you will have a normal stress always acting. And what is sigma x plus sigma y? Sigma x plus sigma y is invariant stress, first invariant stress. It is called first invariant of stresses. Normal stress must be, all normal stresses acting on the planes must be, orthogonal planes must be same. So this one is constant with respect to any. So half of that will always be acting. So this will be always be, so this is sigma x plus sigma y by 2. This is sigma x. And when you add these two, it becomes sigma x plus sigma y. Because that should be equal to sigma x plus sigma y, is it not? So half of this will always be acting. Because you have to substitute. You take the expression for sigma x dash and substitute there this value of theta. So you get only this comes, rest the two expressions, other there are two expressions, one is cosine 2 theta, other one is sine 2 theta. That turns out to be 0. Okay, so you are left only with this. So this is the fact. So on a plane of maximum shear stress, you always have half of the first invariant of stress acting. So this is again a very important theorem or result. This is an important result that you should remember. Okay. Any doubt is there? So then this is analytically, this completes the finding out directions of maximum normal stress, maximum shear stress, and then so you are in a position now to find out these quantities, which are very important. At any point you must know the maximum, not with respect to any arbitrary direction. You must know the maximum values, so that it is done, and that is used in the design, which you will be using in the next course. When you go for steel design or concrete design, so this one will be used. Then okay, just take some example now. There is a example. क्या है? This problem is from Popo book, 3 MPa normal stress, 1 MPa normal stress. Please do not talk. Whenever you draw any element, you please complete it. It should not be incomplete. And the shear stress is to, I think, 3 MPa, 2 MPa. 2 MPa. Okay, so this is the state of stress given at a point P in a body, state of plane stress. Please find out what are the maximum shear stresses, maximum normal stress, direction, etc. for this. So take this, help, start working, and then I will help you. So anyway, just for, I always write, oh yes, what is the, so that whenever I get any results, what is this value? So this is equal to 3 plus 1, 4. So first invariant of stress is 4. This is only for checking purposes. So can you please find out what is the values, principal stresses? Sigma 1, 2. One by 2. गलत हो गया? Where is the mistake? Sigma x minus sigma y is how much? Oh, 2 by 2. Oh, good. Yes. So it is 2 by 2. So this is 1. So this is 1. This is okay. So 5. Oh, you have to find out root of 5. Okay. So 2 plus minus root 5. How to find out root 5? Yes. I play a good game. I remember that. Root 2 you were asking me. I play a good game. So this is 1, this is 4, this is 1, again 4, and this is 4. Put point. This is equal to root 2. Root 2. I didn't remember that time, now it came. So it takes some time to recall from the memory. Okay, good game, गड़बड़ है. Last one, last digit is not. Oh, ठीक है. Anyway, this is. Huh? I play. Okay, something. Okay, I play a game. But I remember a good game. Last one is 1.44. What is the next digit? 2. Anyway. Okay. This is 2. Okay. So anyway, I remember I play a good game. So. But. All right. So this is equal to, this is 2.24. So plus 2 plus minus 2.24. So this is 4.24 or minus then find out the angle. These are the two values. So this is sigma 1, this is sigma 2. See, write clearly. Whenever you write on your notebook, learn this habit. This is not JE. You have to be an engineer. Engineer's language is, it must be very clear. Whenever you write anything, it must be clear. So this is sigma 1, this is sigma 2 MPa. Now what are the angles? Tangent to theta 1 is tau xy. Please do it. Don't waste your time. This time will not come. If you are not doing it, you are wasting your time. This is 2 divided by 2 by 2, that is 1. Please find out the root. Tangent to theta 1 is 2. So it has to be more than 45 degrees. 45 is 1, tangent less than 45 is less than 1. Tangent, so 2. But when it is 90, it is infinite. So somewhere in between. So what is 2 theta? Who will give me the values? Come on. 63 point. No, 63.43. And दूसरा हो जाएगा plus 180 ना. Second root will be no. This one is 2 theta. You have found out 2 theta, na? This is 2 theta. So 2 theta, and the other one will be 180 degrees plus 63.43. नहीं भाई, नहीं 90. 2 theta. Theta is 45. So this one is coming out to be 243 point something. You can find out so many degrees. So therefore theta 1 is half of this 31 point जो भी है 31.215 degrees and plus 90. 31 plus 90. यहाँ पर 180 होगा, यहाँ पर 90 होगा. So 90 कितना हो गया ये? 12 121 नहीं 1 दिस ये कितना हो गया? 121 हो जाएगा ना, 121.21. सो जो भी करना है आप करिए इसको. सो दिस इज 31.71. ओके, so this is 71, 31. So you have to do this. You cannot leave it that somebody teacher will, in examination you cannot say that yes, this is, I have done it, tangent 2 theta equal to 2 and that is all, matter ends there. No, please find out the angle. So now you have to show, then you have to show this on the element. Yes, at the same point, now it has rotated by, and this angle is 31.71 degrees. हाँ, उसका देख लीजिए क्या है. You will have to check whether it is correspond to first root corresponds to this angle. Just check up whether the first maximum na for this, because the values came out to be 4 and 0.24 minus. 4 के लिए क्या है एंगल, ठीक है ना. So this one is positive, yes. So this one is 4.24 MPa. So this is MPa. You will have to check that for this angle, this is the corresponding value. This is a positive, because first 4.24 is a positive stress, sigma 1. Other one is negative. So other one is here like this. This will be, and this value will be 0.24 MPa. So this one is again, the element has rotated by, so this is 4.24 MPa, and this one is 0.24 MPa. Is it clear? You have to do this much, and with clarity, with full clarity. Unless you do this, you don't deserve marks. Don't come for half marks, that I have done half correct and I went there a mistake. If any mistake means you lose everything. We can't afford to do any mistake. This is such simple. You have, it is a concept. So this is the principal stress. Now please check whether this 4.24 and then that is a plus, and this is, the other one is minus point, sum is 4. So this is okay. Original was 4, sigma x plus sigma y also was equal to 4, original. So this is okay. There is no shear stress on these planes. Don't show any shear stress. This is principal directions. These are principal directions. Of course, this one maximum is, there is only one direction which is principal, the maximum. This is principal direction, but we loosely call it principal directions. Both, as if both are principal direction. But actually there is only one on which maximum occurs. So that is a principal direction. Then you please complete 15. Now where is 33, 4? Okay. Now, so I have done already this. Then you please also find out what is maximum shear stress. This is not end. What is tau maximum? tau maximum. And what is the corresponding angle? Theta 2 dash. Dash are 1 dash and 2 dash. 1 and 2 dash. And 1 dash. So करिए इसको. Please find out what is tau max. Yes, tau max is equal to plus minus. तो अंडर रूट कितना हो गया, कितना था हमारा? सिग्मा एक्स माइनस सिग्मा वाई बाई 2 प्लस टाउ एक्स वाई. ये तो टाउ मैक्स हो गया, तो ये कितना हो गया आपका? 2/2. So 1 root 1 square plus 2 square. The same 5 root 5 plus minus 2.24 MPa. So this is magnitude. This is only the magnitude. What about direction? Two theta 2, sorry, tangent that is given by minus divided by tau xy. तो कितना हो गया? माइनस 2, हाँ माइनस हाफ. सो माइनस ये हो गया 1/2 एंड नहीं 2/2. सो ये हो गया 1/2. हाँ. So please find out what is this. We will call it, because theta 2 is all right, but again there are two roots, na? There are two roots, huh? So this is direction is called, because you see, you should not have confusion between 1 and 2 direction for principal. You have 1 and the other one you call 2. So here you call 1 dash and 2 dash. For shear stress, maximum shear directions are 1 dash and 2 dash. So please call them two roots, theta 1 dash, that means 2 theta 1 dash and 2 theta 2 dash. So what are these values? Minus. Tangent negative. Tangent negative किस क्वाड्रेंट में होगा भाई? AC 1 2 नहीं, फोर्थ में भी होगा भाई. Second half. Please find out. Tell your friend. What is happening? What did I say? Find out the value of this one. Come here on the blackboard now, and just give me what is the value of theta 2 theta. What are the values of 2 theta? Both of you. Yes, you have got calculator? Who will find out? Who has got the values? Correct values, because I think there is some minus.
Minus 26.56.
1 2 3 4. Na? This is how we number the quadrant. Na? 1 2 3 4. So tangent negative. Yes, 2 and 4. Huh? 2 and 4. 2 and 4. 2 and 4. कैसे भाई? कुछ समझ में नहीं आ रहा हमको. अच्छा, anyway, find out what is the value. What is theta 2 whose value is 0.5 minus? Because I have got here different value. I have got here, I mean, unless it is a question of interpretation, maybe. I have got here. So, what is the value of 2 theta? Theta, हाँ, आपके हिसाब से क्या आ रहा है ये? माइनस 26 and दूसरा प्लस 180. So दूसरा क्या हो गया? 2 theta 2 dash minus 26.56 plus 180. So ये कितना हो गया? 153.444 degrees. So how will you do this? So minus तो very easy है. Minus means this one 26 यहाँ पर. So 1. So as per you, this element will be like this, and this is x. So minus 26. Sorry. The half of this. So theta 1 dash will be minus 13.28, and theta 2 dash 76.7 degrees. So एक तो minus हो गया 13 degrees. This is 13 degrees. 0.28. ठीक है. दूसरा ठीक है, that is 180. So कैसे this is okay on this. And 76. Then this direction is 76. This direction is 76. So one direction is here, other one is this. So maximum shear. Now which one? What about a direction? Direction कौन सा? No, maximum value you have got. So plus or minus, which one acts on this plane? Plus 1. 2 point. 2 point na plus. So plus has to be like this. And then here it will be negative on this. If it is, this is a correct diagram. I mean, if you are saying ki yes, this is plus, so this is okay. No, plus is this correct. See, this will produce anti-clockwise. So this is okay. So then this is okay. But let me see whether I am getting. Yes. Okay. Diagram is correct. That is right. I have got somehow some different angles. I just do not know. But then this one is okay. This one is okay. So this value is 2.24 MPa. See, these are important. Signs are important. You cannot just leave it. Whether this one should act here like this or this. So that is why I am saying substitute this value in the expression. Then you have to find out. Yes, this happens. So it is like this. So this is correct. And then find out what is the maximum, what is the normal stress acting. Normal stress, of course, is very simple. Normal stress will be sigma, half of sigma x plus sigma y. So that is 2 positive. So 2. everywhere 2. This one is 2. So then only it completes the status. Yes. If you have got any doubt, this is involved in solution of any problem. This much is involved in solution of any problem given to you. If it is given with reference to x and y, you have to find out with reference to 1 and 2. Then you have to find with reference to 1 dash and 2 dash for shear, and then you have to draw this. So this is the maximum shear. These are maximum. So these are the planes of maximum shear, and the previous one was planes of maximum normal stress. So okay. So this is now supposing you are asked that please find out I think I have got it. Some plane is given. In that problem, because this problem is from Popo, so example, second part of the problem says that you have this, and then you have a wedge now. So this is 1, this is 3, this is 3, this one is 2, and then this one should be again 2. All are MPa, and this angle is 22 degrees from vertical, 22.5 degrees. So please find out what is this. Sigma alpha equal to 22.5 degrees. 22.5 degrees plus or minus ये क्या है? माइनस भी वो देखना पड़ेगा भाई. Yes, you are that is right. It is minus with reference to x axis. We are always measuring with reference to x axis. So ऊपर नहीं गए हैं तो minus 22.5, and also find out what is the value of shear. Now whether it will be going this way or this way, that has to be found out. So you also find out what is this. So both these you please find out. Okay. So this is one part. Now I will give you quickly. You can go through this exercise. You can do it on your own. This I have already done now. Enough of. Okay, so there is something called state of pure shear. Sometimes at a point in a body, if you draw a particular element, you will have this kind of state. No normal stress, pure shear point. This you have only shear. Of course, all these must be equal. This has to be equal to this, this has to be equal to this. So let us denote it by this tau, just simple letter tau. There is no normal stress acting in this. I want to find out for this pure shear state principal direction. Principal direction for this. What are the principal? Please find out what are the principal direction. Yes. How did you get 45 degrees? Yes, because this one is tangent twice theta 1 is how much? This is this one, huh? For finding out principal direction, this is, huh? It is reverse. Oh, I'm sorry, not this. Inverse, huh? It's the first one, tau xy. Yes, yes. Tau xy divided by sigma x minus sigma y by. It is this. So there is no sigma x, there is no sigma y. These are the two directions. Though there is no sigma x, there is no sigma y. This is x, this is y. So therefore this is equal to just tau xy, and tau xy is tau by 0. वही ना, sigma x 0 हो गया, so ये 0, so that is equal to infinity. So that means this is equal to 90. ये पाई बाई 2 हो गया. हुआ कि नहीं? And therefore twice theta 1 equal to pi by 2, and therefore theta 1 is equal to pi by 4. Huh? So that means this, if you turn this element, in this direction, and what are the values, please? Sigma 1, sigma, what are the values of sigma 1 and sigma 2? क्योंकि सब कुछ तो 0 है उसमें. First term is 0. What is sigma 1, sigma 2? Sigma x plus sigma y by 2 plus minus under root. Yeah. So under root, so this becomes only under root tau xy square. Is it not? So this is equal to tau xy is how much? Just tau. So it is tau plus minus tau. It is plus minus tau. So you have to now you have to designate which one. Plus will go to which. Anyway, plus and minus means this. See, these are very important. If you don't understand, you will never understand this. Right now, if you don't understand, I am going so slow to explain this. So this direction, this one corresponding to 45, you will find that it is the plus tau that will be operative. And therefore, this element is subjected to this kind of. So pure shear, क्या हो गया? Last direction is wrong, yes. It should be like this. Yes, and these values are tau everywhere. So pure shear gets transformed into pure normal stress. This is a very good interesting result, a pure shear, but then समझ में आ रहा है कि नहीं? So pure shear gets transformed into pure normal stress at the angle 45 degree, and with this, see, if you, I can say why it should be like this. See, this element, if you see, because of this edge, it will, see, this diagonal and this diagonal if you take, so this diagonal will be, see, both sides, here also shear, so it will be under tension, and this will go inside. So finally it will, this element gets transformed into a, what you call this, physics from physics, this is square, and what do you call this? nahi bhai, crystal. Crystal which, what is the name of this crystal? Like this.
Diamond.
It is a diamond, all right, but then, so this diagonal has increased and this diagonal has reduced. The element becomes, shape of the element becomes like this, and therefore your element 45 degree here, I'm drawing the 40, this is small, this element I'm drawing inside. So this is this element. ये जो अंदर का एलिमेंट है, छोटा सा मैं उसके. So this is stresses, that means this side it is increasing, so tension. So this is what is shown here. This inside element is shown here. So these two are extending this diagonal, these two are compressing this diagonal. So this is leads to pure this is extremely important result, a pure shear and vice versa. A pure tension and compression leads to a pure shear state of stress. Have you understood? See, this is going like this is compressing. So when it comes to, again now you visualize in x and y, what will happen? This one, it will be like this. So when you draw an element here, when you draw element inside this, which is this, so on this, it is this. See, point is same. It all depends upon you how big a square you draw around it, and in which direction, what plane you are doing. So I'm taking a same. This means, yes, this will lead to a normal stress here. This and this will be again compression. So this is compressing. So this, you understand the feeling. Yes, this is again this diagonal, because if this is there, so this diagonal is increasing, this diagonal is getting compressed. So there must be this type of. So this is, you understand this, and so mathematically you have derived, but now you also physically, there is no need to do this, but physically one can explain this, that this will go like this. But now you have proved this. So this is, now, so then we'll stop here. But now this whole operation can be done graphically also. Instead of analytically, we have done, now we know all the formulae to find out all these values. Can we do this graphically? And the person who did this graphical invention, his name is Mohr, M-O-H-R, Mohr. So that diagram is called Mohr's diagram. Mohr's diagram, diagram of Mohr, to find out principal stresses. How to find out? So it leads to a circle, because this equation can be, that their transformation equation can be written in the form of equation of a circle. This x dash, y dash, so please find out, this can be written, the transformation equation can be expressed in the form of a circle. See, circle is what? X square plus y square equal to r square. There is that under root thing, that is a under root, and then square of that, and then you say 2 addition on the left hand side. So it can be written in the form of a square, and then it is very easy to draw a circle. So that diagram I will tell you tomorrow means next time, and next time will come on Monday morning at 9:30.